On LR1-8, we're going to use the parallel lines conjecture to understand different types of angles that are formed by transversals, and you'll also be able to determine if lines are parallel based on angles. So a transversal, and I'm going to trace over this a little bit, is a line intersecting two or more other lines in a plane. So it's this line. Maybe. There we go. Okay, so it's the line that's cutting through two other lines or more. My corresponding angles then are two angles that occupy the same relative position at each intersection. So they're in kind of the same assigned seat. So I could say angle 1 and angle 5 correspond. I could say 2 and 6 correspond. I could say 3 and 7 correspond. And that leaves 4 and 8. My alternate interior angles then are going to be two angles that lie on opposite sides of a transversal, but between the two lines. So the alternate tells me, hey, they're on opposite sides. Interior tells me it's inside the lines. So for example, angle 3 and angle 6. Or I could say angle 5 and angle 4. My alternate exterior angles then are just the same thing, two angles that lie on the opposite sides of a transversal. But this time exterior tells me it's outside the two lines. So I could have angle 1 and angle 8. And I could have angle 2 and angle 7. So we're going to do an example. We're asked to describe the pairs of angles. So I have angle 1 and angle 7. We learned these yesterday or in the last lesson. Those are vertical angles. Next, I'm asked to look at 6 and 8. Those are in the same relative position, so they are corresponding angles. Two and 6 are between the lines and on opposite sides, so those are my alternate interior angles. 5 and 6 make a line when they're put together, so that is a linear pair. And then lastly, I have angle 1 and angle 5. Those are on opposite sides of that transversal, but outside of the two lines, so they are alternate exterior angles. Okay, remember parallel lines are parallel if they never meet, and they're always the same distance apart. Remember, we mark them with the little baby arrows. Okay, that should be review. And if I have line A and line B, I can say line A is parallel to line B. Okay, the two little L's means parallel to. All right, so if my lines are parallel and I have a transversal, then my corresponding angles are always congruent. So what this means in practice is that angle 1 and angle 5 will be identical. Angle 2 and angle 6 will have the same measure. 3 and 7 will have the same measure. And 4 and 8 will have the same measure. If we think about it then, we know angles 1 and 5 are going to correspond. Okay, so we just said that, hey, those are going to be the same. Cool. We also know that 4 and 1 are congruent because they're vertical angles, and vertical angles are always congruent. So if angle 1 is congruent to angle 5, and angle 1 is congruent to angle 4, then angle 4 and angle 5 must also be congruent. So we can summarize that by saying if two parallel lines are cut by a transversal, then the alternate interior angles are also congruent. Similar idea. We know angles 1 and 5 are congruent because they correspond. We also know 5 and 8 are congruent because they're vertical angles. Well, if 1's congruent to 5 and 5's congruent to 8, then 1 must be congruent to 8. So I can say my alternate exterior angles are also congruent if my lines are parallel. So if we want to summarize all of that, anytime I have two parallel lines cut by a transversal, all of these things are true. So I end up with 1 and 4 and 5 and 8 all congruent to each other, and 2, 3, 6, and 7 all congruent to each other. Do you have like 3 minutes? Okay. The opposite is also going to be true. So if I know all these things are true, then the lines are parallel. So if I see a picture where 1 and 5 are marked congruent, then I know that my lines are parallel. Okay. Similarly, if 2 and 6 are different, then I know my lines aren't parallel. All right, so we're going to do an example with some algebra in it. So I know this angle measure is 6x plus 12, and I know this angle measure is 3x plus 39. My lines are marked parallel, and I have my transversal cutting in. So I know my alternate exterior angles are congruent. So I'm going to have 6x plus 12 equals 3x plus 39. When I subtract my 3x, I get 3x plus 12 equals 39. Subtract my 12, and 3x equals 27, so x must equal 9. I'm asked to find angle ABD. I'm going to start at A, go to B, turn, go to D. So I'm looking for this angle first. If I plug 9 in, I get 6 times x, which was 9, plus 12. So I have 54 plus 12, or 66. And then some of you are like, oh, and then EFG must also be 66. And you're wrong, and here's why. EFG is not what we were asked for. I was asked to find EFH. So I'm going to start at E, go to F, turn, go to H. This is the angle I'm looking for. So I know this one's 66, which means this one must also be 66. These form a linear pair, so I can do 180 minus 66. 180 minus 60 is 120. Minus 6 more, I'm at 114 degrees.